In section 11, topic 7, we're looking at the surface area of pyramids and cones. So first we're going to look at pyramids because they're a little bit complex. You really have to think about the net diagram of these figures. So if you look at the net of a pyramid, you're going to be calculating the lateral area of all the faces. So the lateral area of the faces is going to be the number of faces times half base times height, because if you picture a pyramid, all the lateral faces are triangles. No matter what kind of pyramid you have, all the lateral faces are triangles. So that's where this half base times height comes from. And then you'll multiply it by the number of faces that there are. So the surface area is calculated from the lateral area, again, all the faces, plus the base area. So the base, so this is different from the prisms and cylinders because there's only one base in all pyramids. So it's the lateral area plus one base is the surface area. So to do this, first you have to identify what kind of base you have. So we have a square base. And if you look at the net diagram, I'm just going to draw it really small. The net diagram for this figure would be a square with triangles for all the faces. We know that the base is 12, so the base area is going to be 12 by 12, and we know that the height of each triangle is going to be 8, so we're looking at that slant height. So each triangle has a base of 12 and a height of 8. So first we're going to calculate lateral area. So lateral area is going to be the number of bases, the number of faces, which is 4, times half. The base of those triangles is each 12, times the height of each triangle is 8. So when we're calculating lateral area, we're doing 4 times half times 12 times 8, and that would be 192. So the lateral area is 192. Now we're calculating the base area. So again, it's important to identify what kind of base that you have. Again, we have a square base. And because we have a square base, the area formula is just base times height or length times width, or you could just do the side squared. So we're looking at doing 12 times 12. And when you do 12 times 12, that is 144. So lastly, the surface area brings everything together. Surface area is the lateral area plus the base area. So surface area for this problem is 336. And whatever it is, if it's inches, units, whatever area is in squared. So units, this time we're going to use inches squared. For the hexagonal pyramid, this is a pentagonal pyramid, there's 5 sides, so 1, 2, 3, 4, 5. So 5 sides, we're looking at the lateral area. So if I was to draw just a little net of what this would look like all flattened out, we would have a pentagon and little triangles off of each side. So there should be 5 faces. Each face is 22, so each height of each of these triangles is 22, and the base of each side of the pentagon is 12. So first we need to calculate lateral area. So lateral area is going to be 5, because again there's 5 faces, times half. The base is 12, and the height of each triangle is 22. So the lateral area would be 5 times half times 12 times 22, which ends up being 660. The base area for a pentagon, it'd be really helpful to use the 11.2 notes for calculating the area of shapes that have more sides than 4, because what you have to do with each base is divide it into little triangles and then multiply by the number of triangles that is made up in that shape. So in this case, in a pentagon, there would be 5 triangles made up. Now sometimes you're going to have to use trig, so you might have to find the apothem, but for this problem I'm going to let you know that the apothem of this shape is 8. So again, if you're trying to find the apothem, the best way is to refer to the 11.2 notes where it talks about using tangent to find the apothem. So the base area is going to be, because it's a pentagon again, we need to calculate the area of one of these triangles formed inside the figure, which would be half, the base is 12, times the height of that inner triangle is 8, or the apothem is 8, times the number that we would have. So we would have 5. So half times 12 times 8 times 5 is 240. And then surface area is those two values added together, lateral area plus base area. So 660 plus 240 would give us 900 units squared. So to find the surface area of a cone, the formula is a little bit different, because if you think about what the net of a cone looks like, it's kind of like a circle as the circular base, and then it's kind of like this pizza slice. Now if you're trying to find volume, it's important to find the actual height of the cone, but since we're only looking for surface area, we're looking for this pie shape. We're calling the length or the height of the side as the slant height. So what we're looking at doing for the lateral area is pi times the radius times whatever the slant height is. So the formula ends up being pi r L. And then surface area again is just the lateral area plus the base area. So just like above. So if we're looking for the lateral area, we're using pi, so 3.14, times the radius, so times 8, times the slant height, again it's that length on the outside of the figure, so it's 17. So 3.14 times 8 times 17 gives us a lateral area of 427.3 units squared. The base area, again, you have to take into account what kind of base you have. We have a circular base, and the area of a circle is pi r squared. So we're using pi times the radius squared. Base area ends up being 296, so 200.96 units squared. Lastly, to find surface area, you add the lateral area plus the base area, so 427.3 plus 200.96, and the surface area is 628.26 units squared for the cone.